change everything that you're doing really fast?
NASA,
That would be great.
Adjust this just for our D4 little tiny school.
So all these identities that you wrote down in your notes, we'll do like we did last year, a little like identities, like cheat sheet quiz thing, before the quiz that you'll be able to use, on it. It's probably the day before, which I don't know when that's going to be yet, but, basically in 2 weeks, we leave for senior trip. So I'll be gone for 6 school days. So I'll figure out what I'm giving you to do at that point. I might pull some old videos for you to watch. I might give you some worksheets, but my goal is prior to that you'll definitely have a quiz. So if not next week, the following week, you'll definitely have a quiz. I won't be here that Friday, so I'm leaning toward before that. And then that following week, we'll kind of wrap up the chapter or get a few more things in the chapter done. So we might go through like 5-4 and then quiz 5-1 to 5-4. Because I think that'll be about where we're at before I need to leave. And then the last couple sections I think they're like law of sines, law of cosines, that I should have some videos out there for. And I know y'all have done it before, so hopefully it won't be too bad, but we'll see what happens. So anyways, so most of these problems are simplifying, like use basic identities to simplify, or simplifying so that it's equal to either like 1 or -1, depending on what the situation is, things like that. So 10 cotangent of x times tangent of x, and we're just trying to simplify that. So I'm looking for ways that I can rewrite one or both trig functions, k or however many are in the equation, obviously this one has 2, in order to cancel things to write it as one singular piece. So how could I rewrite one or both of these? Because there's a couple different ways I could do it.
Cotangent is 1 over tangent of x.
Yep, so this would be 1 over tangent of x times tangent of x, which would cancel and give you 1.
That's nice.
Now, the other thing we could have done, hypothetically, we could have said cotangent is cosine over sine, and tangent is sine over cosine, and we could have canceled this way and gotten that that's equal to 1 as well. So there are often different ways that we can get to the same result, but the one that's in blue is probably slightly easier because, it's a little less writing, but totally up to you. Would be fine either way. 12, cotangent of, they use u's, but I'm going to switch them to x's because u's a weird letter and I just don't feel like it. Cotangent, I don't know. Cotangent of x, sine of x. So, and if you're like, I don't like x, I like theta, you can change it to theta. If you don't like theta and you like x, maybe you don't like x or theta and you want to use u, that's totally fine. I don't really care as long as you're consistent for that particular problem. So, what is something I could rewrite here in terms of something else?
Cotangent is that.
Cosine x over sine x times sine x. So sines would cancel and leave me with cosine x. (16) sine squared, again they use u, so I'm switching it to x. Sine squared x plus tangent squared x plus cosine squared x all over secant of x. So when you see terms being squared, what should you think of?
Those
Pythagorean identity. So it's always good to start there when we see stuff being squared because oftentimes the identities are in place for a reason. So on the top, which identity might we be dealing with initially?
So 1 plus tangent squared, x equals 6 equals.
Okay, so initially sine squared plus cosine squared, so
That's just 1.
this one and this one would be 1. So this is going to be 1 plus tangent squared x over secant of x. And then 1 plus tangent squared, is that an identity?
Yeah, that's secant squared.
So that would be secant squared of x over secant of x, which is just secant of x. Now, sometimes you might also have to manipulate one of those Pythagorean identities. Like if you had 1 minus cosine squared of x, you would say that that's equal to what?
Sine squared of x.
Yep, sine squared of x. So sometimes just know that you might need to manipulate them from where they start in order to be able to use them. I was doing one with, I think it was with Maya this morning, that was, we had to make it negative. Like we had to, like, I think it was 1 plus cotangent squared equals, is it cosecant squared? Is that it?
Yeah.
So we needed cotangent to be negative, so I had to do 1 minus cosecant squared is equal to negative cotangent squared for it to work, right? So sometimes we have to manipulate them in that fashion as well. So just be aware of that. 18, secant of negative x, cosine of negative x. So the first thing you want to do when you have the negatives inside is we want to see if we're pulling them out or if they're just going away altogether. So with cosine and secant, what happens?
They're positive.
Yep, they go the function stays positive, but this inside goes away. So we'd have secant of x, cosine of x. Now what can I do?
1 over cosine, that's times cosine.
Yep, 1 over cosine of x times cosine of x. So we cancel and we are left with 1. How about something like secant squared of negative x minus tangent squared of x? What might I need to do with that?
Change the secant squared negative x to just secant squared x.
Yep, so change this to just secant squared of x minus tangent squared of x. Now, I do want to show you something because obviously with secant, it goes positive, so I don't have to worry about this. But something to remember is that secant squared of x is equal to secant of x squared. So if this had been, and like other ones, let me do, what is it, sine. So like let's say we had sine squared of minus x. This would be equal to minus sine of x squared. So it's going to end up becoming positive because it's being squared. Okay, are we tracking?
Yeah.
Okay, and it would have gone away and been positive. Okay, so that's just something just to note. Obviously, in this case, it didn't make a difference because it goes away altogether. But in other trig functions, it could make a difference. So that's why I wanted to show you that. I don't know if there's any like that, but just in case. So now what?
Maybe make the secant thing 1 over cosine squared x
Oh, it
and
equals 1.
whatnot.
Yes, it's a Pythagorean identity.
Just make it take
Manipulated would be equal to 1. Now, what I didn't tell you is 17 through 22 have to be equal to 1 or negative 1.
Wow, thanks. If you would've told
Because
us-
more than likely what I'm going to do when you get your quiz is I'm just going to say simplify.
Yeah.
And you should know if it can go all the way to 1 or if it can just go, because on the AP exam, if they're asking you to simplify, they're not going to be like, simplify this to 1 or negative 1, because then it kind of makes for an interesting multiple choice question that's
Yeah.
supposed to have 5 answer options and there's
One,
only 2 that make sense. Like, that's like when the teachers put letter C, not this one. Like, I had in college a professor had put like letter E and he was like, the answer is E.
Oh, I would have been so mad.
And I was like, is this a trick?
I've been confused, like.
I was like, am I supposed to do this or not? Like, what's happening?
Like, are we joking or are we being for real right now?
Yeah, I was like, I don't know what's happening. There's a lot of these. Okay. Let's see. Simplify the expression to either a constant or a basic trig function. They say support your answer graphically, but that seems a little excessive, so we're not gonna do that.
Yay.
Because again, you're not inclined to have to do that, so why would we do it now? But if you were so curious, you would basically put in the initial function in y equals, then you would put in the final in y equals, and it should look the same if you were just so concerned about it. All right, so obviously they're going to get a little harder here. I'm sure you just love. But 1 plus tangent of x over 1 plus cotangent of x. Any idea where I might need to start?
Can we square it?
No,
Well, now I know.
it's not mathematical.
I remember something like this one.
So what's my first thing? Always see if I can do what?
Change, like the cotangent.
Okay, to see if I can rewrite something, right? So what are the only 2 things that could be rewritten in this problem at the moment?
The tangent and the cotangent.
Okay, how might I want to rewrite those?
Virginia, go.
What? Maybe as sine over cosine and cosine over sine.
Yes. So 1 plus sine x over cosine x all over 1 plus cosine x over sine x. Now what do I need to do?
The reciprocal thing, or the thing where you do like the times the. I don't know what it's called.
Not sure what you're trying to
I don't
explain.
know, what is it?
I don't think I can do
KCF?
it.
Like the keep, change, flip thing?
No, because then that would
I can't do that because of the 1 plus.
take out. No.
That will be my end goal, is to keep change flip, but I can't do it yet. What would I need to do to be able to do that?
Can we like split that?
No.
Can we factor out a 1?
It's going to do absolutely nothing. It would
Yeah,
just
I
be
agree.
1 times 1 plus cosine over sine. Like, it's not going to change.
more numbers.
If you had... How would you do that?
I don't know.
Okay, let me just do this. If you had this, how would you do that? And don't tell me it's 2 3/5.
Change the thing to
The
the
two
one. So you change the one to have the common denominator.
There we
Oh my
go.
gosh.
Common denominator.
It took way too long.
Woo.
At least y'all eventually got there.
Yeah, exactly.
Class the other day, man, they had me. I was like, y'all. Okay, so cosine x over cosine x, and on the bottom, sine x over sine x. So now each piece can be written as one together, right? So I've got cosine x plus sine x over cosine x all over sine x plus cosine x over sine x. Now what might I do? Keep change flip. So cosine x plus sine x over cosine x times sine x over sine x plus cosine x. And now what?
Tangent. Because you get rid of the cosine x with sine x, and the other thing.
Correct. That's what I wanted you to tell me. Cancel this because those are the same even though they're not written in the same order. So I'm left with sine over cosine, which is tangent of x. Sometimes it's crazy how much work you have to do to get to such a tiny little answer.
Frustrating.
And this isn't the longest one.
Just add a happy ending.
Start one day, I'm gonna work one of these out. It's gonna be like, no solution after 20 steps. I'm like, great.
Riley's going to take 25 steps to get to an answer that Josh takes 3 for.
And then Virginia's gonna get no solution. No, we're all just gonna be like, okay, so how do we all get to different?
No solution is my least favorite answer because it makes me like doubt myself.
It's like, yes, way
It's
too
like,
much.
well, there's a solution. You just couldn't get there.
Yeah.
All right, again, this problem is, wait a minute.
Is it scary?
Okay, they're using U and V, so I'm
X
going
and
to
Y.
use that, or you can use X and Y. I'm just going to use the U and V for right now, but actually, maybe I'll just use U and X.
Okay. The U's and V's get confusing.
I don't really know why it needs to be 2 different letters in this situation because the end result isn't going to change if they were the same or if they were different, but
Because it's no solution.
no,
Dang it. Okay.
it's
well,
not no
we'll try.
solution. What's secant squared minus tangent squared? 1. What's cosine squared plus sine squared? 1. So the answer is
So it's 1.
1.
Okay.
Look how nice that
That was
was.
very nice.
I'm glad we knew one of the ones won. I'm glad you remember that.
Some classes, they stress me out, man. I'm like, what is anything raised to the 0 power? And they like, 0. And I'm like, no!
Like, it's anything but 0.
I'll
Man.
be honest, I just learned that this year. Like, really learned it.
Oh,
Really
I thought you already
good.
knew that.
Yeah, like I kind of forgot. Fair enough.
All right, I'm using thetas in this problem because I
It
can.
hasn't had its time to shine yet.
Correct.
Today.
I've got sine theta minus tangent theta cosine theta plus cosine of pi over 2 minus theta. Another thing that I'm just going to point out to you really fast, which is not really relevant for what we're doing at this very moment, but next year in calculus would be relevant. Okay, if a problem starts you out with something like this, what should your answer or what should your calculator be in if you're trying to solve it? Radians. They had a problem the other day and I was like, if it gives you an interval from 0 to pi over 3, what might your calculator need to be in? And they were like, I'm so glad you said that because I was in degree mode and I was like, yeah, and your answer would have been wrong too. So always pay attention to that because, on the exam I won't be there to remind you of that. But yes, if you see anything with pies, you should be in radian mode.
Okay.
If your answer looks suspicious, check.
All right, so sine to theta I can't rewrite right as anything else specifically. How about that middle piece? What might I need to do with the middle piece?
Sine over cosine.
Yep, sine theta over cosine theta times cosine theta plus
Sine theta.
sine theta. It's the one that's a cofunction identity, right? What's the name of that one? Those ones I always think are weird. Yeah, they are. All right, so cosines cancel. These sines cancel, right? Because sine minus sine is 0. So I'm just left with sine theta. Go ahead and set this problem up. I don't know if we'll get through it all, but we'll try. 32. Secant squared of x cosecant of x over secant squared of x plus cosecant squared of x.
I don't like the way that sounds.
Let's just say it took a a few lines.
20?
No, not that many.
Okay. Well, then that I can.
At a minimum 9.
Okay.
That's if you write like fractions and fractions in one line.
Oh, in one line.
Okay.
Because otherwise every step is 4 lines unless you work side to side instead of up and down. All right, so what might I be able to rewrite here? I see some squared things, so first check and see if there's anything that can be rewritten. I'm not saying that there can be, but check and see.
I we could do
Don't
that unless we manipulate it horribly.
Yeah. Without some mass chaos, we cannot use those. So, how can I rewrite each of these things that are up here, though?
So secant is 1 over cosine. Cosecant is 1 over sine.
Okay, so the first piece is going to be 1 over cosine squared x times 1 over sine x all over 1 over cosine squared x plus 1 over sine squared x. Also, thank you for not telling me to cancel a cosecant on the top and the bottom and the secants on the top and the bottom, because I have people do that too, and it just...
Like when you said the plus, it was like, no.
You thought it was going to be easy till I said that?
Yeah, the plus.
All right, so hypothetically here, what might I need to do?
Maybe the common denominator thingy we did earlier.
So I need to multiply this one by sine over sine, cosine squared over cosine squared, sine squared over sine squared, and cosine squared over cosine squared. So that means on the top I've got sine of x times cosine squared x over sine x cosine squared x oh, wait a minute. Something's wrong.
Here we go.
If you figure out what's the problem.
Well, I
Then
think
they're
it's
really
that
obvious.
denominator there, but
Well, it's the denominator.
sine squared x. I mean, I don't think it's supposed to just reduce to 1 on the top there. But I don't think that's gonna get us any. Not that statement. Virginia, do you have any ideas?
You have 1 minute to figure it out.
No.
Because the bell will ring. When the bell rings, you lose the opportunity.
Shouldn't there be more than just one sine of it?
Could it possibly
Or
be?
what? Like,
Do we have to split them?
I don't feel like it's gonna cancel on the bottom.
yeah, isn't it
It's not this step that I'm working on. That's the problem.
It's what we've already written.
Is it the multiplying?
What do you mean?
So were we supposed to put parentheses around things?
No, that doesn't matter.
Oh.
I mean, it does, but that's not what I'm going for. I just didn't feel like writing a million of them.
Secant and cosecant, dude. I don't know.
What math am I doing on the top?
Multiplication.
So do I need a common denominator?
No.
No.
See, okay, you know what's funny? That was going through my mind when I was doing it. I was thinking, like, you know what?
Whatever.
We tried.
Yeah, well, we love to get extra steps.
Yeah, this seems to be the most fast.
The top of this should have just been 1 over cosine squared x sine squared, or sine of x is what the top of that should be. But we're going to finish this problem on Tuesday.
Okay.
Okay? But yes, I was like, oh man.
Far away.
I was like, it was multiplying. Why did I do that?
Oh, well, wasn't that the one who said common denominator?
Huh?
Wasn't that the one who said common denominator?
Yeah, but,
So technically it's my fault, I'm sorry.
well, you didn't get the cookie point anyways.
Yeah,
It's
I
fine.
know.
So I guess it cancels out.
No.